Hello everyone, welcome to Pete Maxwell YouTube channel. Today we're going to explain some of all the parameters within the advanced parameters menu. So this is the welcome page. Go to the enter system and go to menu and go to log yourself in as factory user. And then go to advanced parameters, and this is what you see. Now in the other videos we've already discussed about what is temperature weighting and how does it work. The factory default is 0, which means the temperature weighting function was turned off, and this is the display switch between Celsius and Fahrenheit. If you want to change the display to Fahrenheit, just tap on this button and it will switch back and forth. And this is output buffer, which only takes effect when the output is 4 to 20 milliamps. It only works for analog outputs because in some of the application the the heater or the load is vulnerable when the output increase from 0 to 100% quickly, like in 1 second. So the output buffer offers an opportunity to slow down the output increase. Maybe if this parameter is not here, it takes about 1 second for the output increase from 4 milliamps to 20 milliamps within 1 second. But if you can set the output buffer as 50%, then it's going to take two seconds. If I want the increase even slower, I can go for let's say 20%, which means it takes about 5 seconds for the output increase from 4 milliamps to 20 milliamps. So it's kind of protect the load from being damaged due to a sudden increase on the load. This is the input selection. The default is type S. You can change to different inputs according to your local sensor, whether it's type S, type B, type R, or type K. And this is the setting value maximum higher limits. It's pretty useful feature if you don't want the operator at the site to input a very dangerous setting value in the system. You can kind of put a safe limits here. Let's say 1200 degrees is the highest temperature you want in your system. You can put that here. I would go for 1300. And a DA high calibration, this only works for the analog outputs. Let's say if you order a controller with 4 to 20 milliamp outputs, but instead of getting 20 milliamp outputs at the maximum output, you are only get like 19 milliamps. When this happens, you can adjust, you can fine-tune this parameter and try to get the maximum analog outputs, which is 20 milliamps. The default value is 3200. And down here you have the OP1 limit and OP2, OP3. This only works for the SSR drive outputs. I want you to take a look at the wiring diagram of our controller. You can see from terminal 9, terminal 10, terminal 11, and terminal 12, these terminals are for SSR drive outputs. So instead of one output, our controller has 3 separate outputs, which means you can drive a lot of solid state relay compared to one single output. So what's the, so you may ask, what's the wiring diagram has anything to do with these OP1, OP2 output limits? You can configure the output all the same at 100%, or you can configure certain output as 50%. Let's say you are using the OP1 to control one solid state relay, and you're using OP2 to control another solid state relay. When the OP1 got 100 outputs, the OP2 only got 50% of outputs, because in some of the oven, they have different layer of heaters which controlled by separate outputs. With this function, you can generate different power for different layer of heaters. So this is the main idea. And over here, you have the power of protection. This parameter is pretty simple. When you're running the controller in field application, something wrong could happen, and the power supply to the system might be cut off by accident or by unstable supply from the station grid. When that happens, the power of protection on will make sure that the controller keep running the profile after the power resume. I can give you an example of, let's go back to the recipe. So now we're going to run the controller. Going to run the controller. And all of a sudden the power was cut off unexpectedly. Let's cut off the power and see what happens after the power resume. So the power cut off. Let's put the power back on. Now before the power was cut off, the controller was running on certain profile. You can see that right after power on, the controller is still running. It's not stop. It's not on stop mode. Okay, that's because we turned the factory power turning. That's because we've turned the power of protection on. You can turn it off like this. Now you have turned off the power of protection. I can turn it on like this. So now you get the idea. Let's continue to talk about the SV startup method. I'm gonna have to log myself in as factory to have full access to help me with the explanation. The SV startup method, the factory default is starting from PV. Remember, the controller consider the starting point of any profile as 0 degree, but in real application, there will always be some kind of inputs. For example, if you place your controller in the office or in the factory floor, there will be ambient temperature in that environment, such as 25 degree, 23rd degree. So if you look at the, let's look at the recipe. So here's the recipe. Let's say my recipe is from 0 degree to 200 degrees within 20 minutes. And after 20 minutes, the temperature is supposed to be at 200 and then hold the temperature at 200 for 60 minutes. Let's load the program.